Hello students, welcome to Saraswat classes. Now we will be solving the Pubdet 2019 questions as we were doing. The question here is the number of atoms Z in a unit cell of a face-centered cubic metallic crystal is related with the density of the crystal rho, diameter d, and mass of an atom is m as. Okay, so we got to find out the relationship. So we know the density for a crystal, which is obviously rho, is related to Z, which is the number of atoms in a unit cell or called the rank of the cell, and multiplied by mass of the element present in the crystal. And then we have Avogadro number Na times the or multiplied with the volume, and where volume we know is A cube, where A is the edge length, okay, where A is the edge length. So for a face centered, okay, please understand, for a face centered cubic cell, so you try to draw a cube like that first, okay, and out here the atoms how they are present. So you will be occupying all the 8 corners, okay, like that. Okay, and then you consider the this is the top face, down, left hand side, right hand side, back side, front side. Okay, now please understand one thing over here. All the spheres over here, this is the face diagonal. Okay, this is called the face diagonal. Okay, now these are face diagonal, so all the atoms over here are touching each other. Okay, so we can think, what we can think out here is that there is a square. Okay, okay, like this we have a sphere, then we have another sphere like that, and then we have another sphere like that. Okay, something like that. And say if we join these points like this, okay, if we join these points like this, all right, so here, from here to here, this is the A, okay, and from here to here, this is the A, okay, from here to here, this is the edge length A. So using Pythagoras theorem, we can call this face diagonal as to be root 2a, and that is equal to what? R 2r r. So that is equal to 4r. Okay. Now that means we can say 2r equal to d. All right. Or we will call this as root 2a by 2, or we can say a equal to root 2. So that is the relationship between diagonal and with that of the edge length. So what is your edge length out here? This is the A. Okay. From here to here, that is the A. That is your edge length. So we got the relationship between D and that of the edge length. Alright, now we're going to rearrange the equation 1 out here and write it in terms of, so we have Z and Z is equal to what? We will say rho Na into V, where V is the volume by M. Okay. Now out here we already know that Na is a constant because it is a Avogadro number. So we can write Z proportional to rho A cube by M, isn't it? Or we can write or Z equal to, we can say proportional to rho root 2D whole cube by M, or we can ignore the constants and simply write it as rho D cube by M. So if we check with the answers, then what we will find is that the correct answer out here is going to be B. Okay, so that should be our correct answer. Next, and an ideal gas of a fixed mass at the initial state is transformed separately to a different final state B and C by isothermal reversible expansion and reversible adiabatic expansion. Okay, if the transformations B to C is isochoric change and the pressure at the state B is P2 and that at the state C is P3, then we got to find out the relationship between the pressures. Okay, how to do? We'll use the PV graph over here. Okay, so what we need to do is to draw a good pressure versus volume curve graph. So we'll take the P in the y-axis, V in the x-axis. All right. We will identify it a state, suppose A, which is undergoing a isothermal change. Okay. So we will say something like that. And suppose it is going to state B. Okay. So it is going from A to B and they are saying expansion. So keeping that in mind, what will you say? That's it is going to increase its volume, say from V1 and it is going to V2. Alright, now check again. It says it is going, so this is the A to B is the isothermal process, whereas from A to C is a reversible adiabatic expansion. Okay, that means you're going from here to here, and that is your C, and there also there is an expansion. So again you're going from a volume V1 to volume V2. You're going from V1 to volume V2. Okay, and there is a expansion. Okay, there is a expansion. All right, now if you go from the state C to B, okay, like this, then it is called as a isochoric process. So let us now identify. Okay, this is your isothermal. Okay, that process is your adiabatic. All right, and there is no volume change. See, V remains as V, so obviously this is isochoric. Is it not so? Now, assume when at it was A state, it was P1, comma V1. When it is going to state B, it is P2 comma V2, but when it is going to state C, it is P3 yet comma V2. Is it not so? Alright. So if you think that way, right, and just from the graph you can get the answer. As you can see, mark the pressure corresponding to the state C. Mark the pressure corresponding to the state B. Your pressure is increasing obviously in this direction. So this one obviously is your P3 and this one obviously is your P2. So using the graph itself you can say, sir, that P2 is going to be greater than that of P3. There is no doubt about it. So what we will we say? That our answer over here is going to be A. Simply using the graph. Alright. Next question. Question number 6. So this was question number 5. At a constant temperature, okay, that means Ti initial and T final both are same. So what is the change of temperature? You will say 0. Ideal gas, that means it is following the equation PV equal to nRT, is expanded freely. So it is getting expanded. Okay. So obviously delta V out here is not equal to 0. Okay, that means we can say Vi initial is not equal to V final. But free expansion means P external is equal to 0. So we know. So it says the process, for this process, the quantities, the values of the quantities will be auto-defined. So we know PEXT into delta V is the work done. Isn't it not? Now, out here, if the P external is equal to 0, so what we will say that W, which is the work done, if this is 0, then obviously this is going to be 0. Is it not so? Then we also know what? That delta H is Cp del T and delta U is Cv delta T. Now since delta T is equal to 0, so we will say delta H equal to 0. Similarly, that is also equal to 0. Okay. We again know from first law of thermodynamics that Q, okay, we know that Q is equal to U plus W. So if these two are 0, obviously out here this is going to be 0. So if we compare now, we will say that our answer should be over here equal to C. Okay. So I hope that explains how to solve this type of questions. Okay. Keep visiting us for the next videos and the solutions. Thanks for listening. Have a great day.